Here is an example that appears more complicated, but can be solved in a straightforward way. How many moles of P and O2 are formed when 0.378 moles of P2O5 decompose? As always in a problem where we are quantifying a reaction, we first need a balanced equation. Decomposition is when a compound breaks down into simpler materials, in this case the two elements. A balanced equation would have 2 moles of P2O5 react to form 4 moles of P and 5 moles of O2. The link between P and P2O5 is 4:2, which comes from the coefficients in the balanced equation. Starting with the amount given, the conversion factor is constructed with P2O5 in the denominator. Calculation yields 0.756 moles of P. The link between O2 and P2O5 is 5:2. Starting with the amount given, the conversion factor is again constructed with P2O5 in the denominator. Calculation yields 0.945 moles of O2. Here is another example. How many moles of arsenic and dichlorine are formed when 2.28 moles of arsenic trichloride decompose? In this case, we need to come up with the chemical formulas before balancing the equation. Arsenic trichloride is AsCl3, arsenic is As, and dichlorine is Cl2. A balanced equation would have 2 moles of AsCl3 react to form 2 moles of arsenic and 3 moles of Cl2. The link between arsenic and AsCl3 is 2:2, which comes from the coefficients in the balanced equation. Starting with the amount given, the conversion factor is constructed with AsCl3 in the denominator. Calculation yields 2.28 moles of As. The link between Cl2 and AsCl3 is 3:2. Starting with the amount given, the conversion factor is again constructed with AsCl3 in the denominator. Calculation yields 3.42 moles of Cl2.